Morning students, we have started with a new topic in the organic chemistry, namely alcohols, phenols and ethers. Introduction for the alcohols, phenols and ethers is given, that is simply based on the functional group present in them. OH is for the alcohols are the aliphatic or aromatic hydroxy derivatives of aliphatic or aromatic compounds, in which OH group is attached to the saturated carbon are called alcohols, whereas phenols are the hydroxy derivative of aromatic organic compounds, in which OH group is attached directly to the nucleus of benzene. Okay, whereas ethers are the type of organic compound having O- as the functional group, means around the oxygen atom there must be a similar or a different organic group must present, they are called as ethers. We already studied the nomenclature, classification for alcohols. We studied based on the number of OH groups: monohydric alcohols, dihydric alcohols, trihydric alcohols. We given you the example: ethyl alcohol, methyl alcohol are monohydric, ethylene glycol is for dihydric, glycerol is for trihydric alcohol. Similarly, phenols you can classify as a mono, di and tri. Phenol, cresol are the example for monohydric. Phenol, catechol, resorcinol and phenol are the example for dihydric phenol. Pyrogalol and chloroglycinol are the example for trihydric phenols. There is another type of classification is there for alcohol based on the nature of carbon to which OH group is attached. They may be classified into primary, secondary as well as tertiary alcohols. Or CH2OH is for primary, or R-CHOH is for secondary, or R-COH is for tertiary alcohol. Methyl alcohol, ethyl alcohol are for primary, isopropyl alcohol is for secondary, tertiary butyl alcohol is for tertiary alcohols. Similarly, ethers can be classified into simple ethers and mixed ethers based on the groups present around the oxygen atom in a compound. If two groups present around the central oxygen, if both are same, then it are considered as a simple ethers. If you have a different groups around the central oxygen, they are called as a mixed ethers. Only one type classification. ಎರಡು ಕಡೆ ಸೇಮ್ ಗ್ರೂಪ್ ಇದ್ರೆ ಸಿಂಪಲ್ ಈಥರ್ಸ್, ಎರಡು ಕಡೆ ಬೇರೆ ಬೇರೆ ಗ್ರೂಪ್ ಇದ್ರೆ ಮಿಕ್ಸ್ಡ್ ಈಥರ್ಸ್ ಅಂತ ಹೇಳಬೇಕು. Then also we studied nomenclature of the alcohols according to IUPAC system. We studied the alcohols. Let us have some examples for phenols. ಒಂದು ನಮಗೆ ಗೊತ್ತಿದೆ, taken into granted that many common names for aromatic compounds have been accepted as IUPAC names. We studied already. If possible, we can give the name for those compounds also. Let us take some examples for the phenols also. Phenol as it is. If you have a octocresol to the benzene ring, if OH and CH3 is there at octo position, this is called O-cresol in general. According to PUC system, it must be named it as a 2-methyl phenol, because phenol itself is taken into granted that it is a IUPAC name. If you have metocresol, how can you name that? If you have metocresol with you, this is a common name is metocresol. Metocresol means by giving number 1 to the OH group carbon, 2, 3, 4, 5, 6. Therefore, it becomes 3-methyl phenol. 3-methyl phenol is the compound. ಅದೇ ರೀತಿ paracrisol ಇದ್ರೆ 4-methyl phenol will be the name for that. If you have a catechol, you studied already. Catechol ಇದೆ, ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ಹೇಳ್ರಿ. At the carbon number 1 and 2, there are 2 OH groups successfully attached at the carbon number 1 and 2. You studied already. It is a structure for catechol. Its name is 1,2 dihydroxy 1,2 dihydroxy benzene. 1,2 dihydroxy benzene is the IUPAC name for catechol. You can take the quinol. In the carbon number 1 and 3, there are 2 OH groups attached. Carbon number 1 and 4, 2 OH groups attached. It is called as a resorcinol. Resorcinol. Therefore, its name must be 1,2,1,4 dihydroxy 1,4-dihydroxy benzene. Like this. I'll take one example under trihydric. At the carbon number 1, 3 and 5, if there are 3 OH groups attached, then it is called as a fluoroglycinol. According to common system, they are called it as a fluoroglycinol. Its common name must be 1,3,5 trihydroxy benzene. Okay. This is regarding nomenclature of the phenols. We'll take some example under ethers. If you have dimethyl ether means its formula must be CH3OCH3. Its impact name must be methoxymethane. ಸೆಂಟ್ರದಲ್ಲಿರ್ತಕ್ಕಂಥ ಆಕ್ಸಿಜನ್ ಅನ್ನು ಸೇರಿಸಿ ಬಲಭಾಗದಲ್ಲಿರ್ತಕ್ಕಂಥ ಗ್ರೂಪ್ ಅನ್ನು ಸೇರಿಸಿ ಅಲ್ಕಾಕ್ಸಿ ಮಾಡಬೇಕು. ಆನಂತರ ಉಳಿದಿರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ ತಕ್ಕ ಹಾಗೆ ಮೀಥೇನ್ ಈಥೇನ್ ಪ್ರೋಪೇನ್ ಅನ್ನಬೇಕು, ಮೆಥಾಕ್ಸಿ ಮೀಥೇನ್. If you have ethyl phenyl ether, ethoxybenzene, no, yes. If you have diethyl ether is the name for the compound C2H5O C2H5. Its impact name must be ethoxyethane. Ethoxyethane is the IUPAC name. If you have anisole to the benzene ring, if oxygen is attached along with the methyl group, it is called anisole in general. In general, it is called anisole. Its impact name must be methoxybenzene. Clear? What group is there at the right side of the oxygen? Along with oxygen, that right side group must be named it as a alkoxy, methoxy, ethoxy, propoxy, butoxy ಅನ್ಬೇಕು. ಮತ್ತೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಗ್ರೂಪ್ ಯಾವುದಿದೆಯೋ ಅದರಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ಗಳನ್ನ ಕೌಂಟ್ ಮಾಡಿ ಮೀಥೇನ್ ಈಥೇನ್ ಪ್ರೋಪೇನ್ ಅನ್ಬೇಕು. ಅಕಸ್ಮಾತ್ ಏರೋಮೆಟಿಕ್ ಗ್ರೂಪ್ ಅಂತಿದ್ರೆ ಬೆಂಜೀನ್ ಅಂತ ಕರಿಬೇಕು. ಓಕೆ, ದಿಸ್ ಈಸ್ ರಿಗಾರ್ಡಿಂಗ್ ದ introduction, classification and nomenclature of all alcohol, phenol and ethers we studied. ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬಾರ್ದು, ಯಾಕಂದರೆ IUPAC ನೇಮನ್ನು ಈ ವರ್ಷನೂ ಕೊಡ್ತೀವಿ ನಾವು. ಫಸ್ಟ್ PUC ಕಲ್ತ್ಬಿಟ್ಟಿದೆ ಸರ್, ಮತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ಪದೇ ಸ್ಟಡಿ ಮಾಡೋದು ಅನ್ನೋದು ಬೇಡ. At least for 1 mark we are going to provide you one example to name according to UPAC system. ಎರಡನೇದು, many of the questions or some of the questions, not many, some of the questions we are going to frame in the question paper will be according to UPAC system. Common name ಕೊಟ್ಟರೆ ಎಲ್ಲರೂ ಬರೀತಾರೆ ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೆ, ಸ್ವಲ್ಪ ಮಟ್ಟಿಗೆ ಅದು ಡಿಫಿಕಲ್ಟ್ ಆಗಲಿ ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೋಸ್ಕರ ನಾವು ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಕಾಮನ್ ನೇಮ್ ಅನ್ನು ಬಳಸೋದರ ಬದಲಾಗಿ we are making use of the UPAC names. Okay, ಅದಕ್ಕೋಸ್ಕರ it is better to practice both common and IUPAC names. Let us go for separate now onwards. ಇನ್ಮೇಲೆ ನಾವು ಕಲ್ತ್ಕೊಳ್ಳೋದು separate alcohols, separate phenols, separate ethers. Different methods of preparations for alcohols we have to study. Different methods for preparation of phenols we have to study. Different methods for preparation of the ethers ಅನ್ನು ಕಲ್ತ್ಕೊಂಡು ಅವಾಗ ಅದಕ್ಕೆ ಸಪರೇಟ್ ಆಗಿ ಪ್ರಿಪರೇಷನ್ ಕಲ್ತ್ಕೊಂಡ ತಕ್ಷಣ ಬ್ರೀಫ್ಲಿ ರಿಗಾರ್ಡಿಂಗ್ ದಿ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್, then details of chemical properties must be studied. If any chemical property is having any mechanism, that we have to study immediately. Okay, uses ಅಷ್ಟೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಇರೋದಿಲ್ಲ. ಹಾಗೆ ಫಿನಾಲ್ಸ್ಗೂ ಸಹಿತ ಬೇರೆ ಬೇರೆ ಮೆಥಡ್ಸ್ ಅನ್ನು ಕಲ್ತ್ಕೊಂಡು ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಕಲ್ತ್ಕೋಬೇಕು. ಈಥರ್ಸ್ಗೂ ಸಹಿತ ಪ್ರಿಪರೇಷನ್ಸ್ ಆದ್ಮೇಲೆ ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನು ಕಲ್ತ್ಕೋಬೇಕು. ಸ್ವಲ್ಪ ಲೆಂದಿ, ಇದ್ರ ಮೇಲೆ ನೀವು ಹೇಳಿದ್ರಲ್ಲ ಯಾವುದನ್ನು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡೋ ಹಾಗಿಲ್ಲ. ಸ್ವಲ್ಪ ಮಟ್ಟಿಗೆ ಈಥರ್ಸ್ ಅನ್ನು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಬಹುದೇನೋ, ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಕೇಳ್ತಾರೆ ಎಲ್ಲ ಅಂತಲ್ಲ, ಬಟ್ ಫಿನಾಲ್ ಮೇಲೆ ಮಿನಿಮಮ್ 2 ಅಥವಾ 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಇರಬೇಕು. ಆಲ್ಕೋಹಾಲ್ ಮೇಲೆ 2-3 ಮಾರ್ಕ್ಸ್ ಇರಬೇಕು. ಈಥರ್ ಮೇಲೆ 1 or 2 ಮಾರ್ಕ್ಸ್ ಇರಬೇಕು. ಸೊ ದೇರ್ಫೋರ್ you are not supposed to neglect any part, especially regarding preparation and properties. Let us consider different methods of preparation of alcohols. This especially primary alcohol ಬಗ್ಗೆ ಇರುತ್ತೆ. It's taken into granted that though I am giving the heading as alcohol generally, but it is taken into granted that what method we are applying to prepare the alcohol, it is mainly concerned to primary alcohol. Similarly, the properties also. We will consider an important method from Grignard reagent. ಅಂದ್ರೆ ಹೇಳಿದ ನಾನು ಒಂದು 3-4 ಕಡೆ Grignard reagent ಬಗ್ಗೆ ರಿಪೀಟ್ ಆಗುತ್ತೆ. ಒಂದು ಕಡೆ ಕಲ್ತ್ಕೊಂಡು ಬಿಟ್ರೆ ಪರ್ಫೆಕ್ಟ್ ನೆನಪು ಇಟ್ಕೋಬೇಕು. ಇಂಪಾರ್ಟೆಂಟ್ ಆಲ್ಸೋ. The organic compound having R MCX are called Grignard reagent. They can be defined as a organomagnesium halides. In place of R, it may be a aliphatic compound, it may be aryl group, it may be aryl group, but it never be a hydrogen. Usually ಹೇಳ್ತಿರ್ತೀವಿ ಕೆಲಸರೆ ಯಾವ್ದಾರ ನಾವು ಫಾರ್ಮುಲಾ ಬರೆದಾಗ R may be a hydrogen, may be a methyl ethyl propyl group ಅಂತೀವಿ. Grignard reagents ಅನ್ನು ತಯಾರಿಸೋ ಟೈಮಲ್ಲಿ ಆರ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇರಕ್ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಆರ್ಗ್ಯಾನೋಮೆಗ್ನೀಸಿಯಂ ಹೆಲೈಡ್ಸ್ ಅಂತೀವಿ. ಕ್ಲಿಯರ್? ಸೊ ಫಾರ್ ಇದನ್ನ ಕನ್ಫ್ಯೂಷನ್ ಅವಾಯ್ಡ್ ಮಾಡಿ ಇಲ್ಲಿ ನೋಡಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ RCH2OH ಇಸ್ ದ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಫಾರ್ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ ತಾನೆ. ಈ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ತಗೊಂಡಾಗ ಮೀಥೈಲ್ ಆಲ್ಕೋಹಾಲ್, ಅದೇ ಟೈಪ್ ಮಿಥೈಲ್ ಈಥೈಲ್ ಪ್ರೊಪೈಲ್ ತಗೋಬಹುದು, ಹೈಡ್ರೋಜನ್ ತಗೋಬಹುದು. ಆದ್ರೆ ಗ್ರಿಗ್ನಾರ್ಡ್ ರಿಯೇಜೆಂಟ್ ಅಲ್ಲಿ ಆರ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ತಗೊಳ್ಬಾರ್ದು. ಇಟ್ ಮಸ್ಟ್ ಬಿ ಅ ಮಿಥೈಲ್ ಈಥೈಲ್ ಪ್ರೊಪೈಲ್ ಗ್ರೂಪ್ ಲೈಕ್ ಅಲ್ಕೈಲ್ ಗ್ರೂಪ್ ಇರಬಹುದು, ಅಥವಾ ಅರೈಲ್ ಗ್ರೂಪ್ ಲೈಕ್ ಬೆಂಜಿನ್ ಇರಬಹುದು, ಅಥವಾ ಅರಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಲೈಕ್ ಬೆಂಜಿಲ್ ಗ್ರೂಪ್ ಆದ್ರೂ ಇರಬಹುದು ಅನ್ನೋ ಮಾಹಿತಿಯನ್ನ ಪರ್ಫೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ರಿ. ಎಕ್ಸ್ ಅಂದ್ರೆ ಹೆಲೋಜಿನ್, ಕ್ಲೋರಿನ್, ಬ್ರೋಮಿನ್ ಆರ್ ಅಯೋಡಿನ್. ಮತ್ತೆ ಇನ್ನೊಂದು ಮಾಹಿತಿ ಹೇಳಿದ್ದನ್ನ ನೆನಪಿಸ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ ಅಷ್ಟೇ. If in place of R, if you have a smaller group like a methyl ethyl, and in place of X, if you have a highly reactive halogen like iodine, preparation and getting the product is comparatively easier. ಹಾಗಂಕೊಂಡು ಹೈಯರ್ ಗ್ರೂಪ್ ತೆಗೆದುಕೊಂಡ್ರೆ ಬರೋದೇ ಇಲ್ಲ ಅಂತ ಸ್ವಲ್ಪ ಡ್ರಾಸ್ಟಿಕ್ ಕಂಡೀಷನ್ಸ್ ಗಳ ಅವಶ್ಯಕತೆ ಇದೆ. First I will write the statement left side, then I can write the reaction. Formaldehyde with Grignard reagent giving rise to primary alcohol. Any aldehyde other than formaldehyde like estaldehyde, benzaldehyde, any other aldehyde with the Grignard reagent giving rise to secondary alcohol, whereas the ketone with the Grignard reagent giving rise to tertiary alcohol. Important for both the theory exams and also for the competitive exams. Product ಅನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಲೆಫ್ಟ್ ಸೈಡ್ ತೆಗೆದುಕೊಂಡಿದ್ದು ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ವಿತ್ ಗ್ರಿಗ್ನಾರ್ಡ್ ರಿಯೇಜೆಂಟ್ ಇದೆಯಾ, ಅಥವಾ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಅನ್ನು ಹೊರತುಪಡಿಸಿ ಇನ್ಯಾವುದೋ ಆಲ್ಡಿಹೈಡ್ ಇದೆಯಾ, ಅಥವಾ ಆಲ್ಡಿಹೈಡ್ ಇಲ್ಲವೇ ಇಲ್ಲ ಕೀಟೋನ್ ಇದೆಯಾ ಅಂತ ನೋಡ್ಕೊಂಡು ಡಿಸೈಡ್ ಮಾಡ್ರಿ. HCHO ಅಂತಕ್ಕಂಥ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ವಿತ್ ಗ್ರಿಗ್ನಾರ್ಡ್ ಇದ್ರೆ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್, ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್. Then except formaldehyde, if you have a other aldehyde, you will get secondary alcohol. If you take a ketone with a Grignard reagent, you will get tertiary alcohol. We will take example for each one. HCHO is formaldehyde plus methyl magnesium iodide. I will take the simplest and the easiest compound we can make use without any much more difficulties. When formaldehyde is made to react with the Grignard reagent, methyl magnesium iodide in ether medium, initially we are getting the addition compound. This addition compound on acid hydrolysis. It gives CH3CH2OH plus MgIOH. Immediately if you look at the product, you feel difficult to name it because it's looks little odd to give the name of the compound. Adakke ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ವಿಚಾರ ಮಾಡ್ರಿ. CH3CH2OH ಅಂತ ಓದ್ಕೊಳ್ಳಿ. That is nothing but ethyl alcohol. ಹೌದಾ? This is primary alcohol. ಅದೇ ಟೈಪ್ ಎರಡನೇದು ಹೋಗಿ this is formaldehyde. ಲೆಫ್ಟ್ ಸೈಡ್ ಬರ್ದಿಲ್ಲ. Formaldehyde with methyl magnesium iodide giving rise to addition compound which on acid hydrolysis giving rise to ethyl alcohol. Second, any other aldehyde ತೆಗೆದುಕೊಳ್ಳಿ. CH3CHO. I will write like this. Anyhow you can write. CH3CHO is estradiol with the same compound methyl magnesium iodide CH3MgI in presence of ether medium. You will get CH3CHOMgI. It is an addition compound. This on acid hydrolysis you will get CH3CHOH CH3 plus same byproduct MgIOH. ಇದನ್ನು ನೋಡಿದ ತಕ್ಷಣ ಹೆಸರು ಕೊಡಬಹುದು. ಮತ್ತೇನಾರ ಡಿಫಿಕಲ್ಟ್ ಅನ್ಸಿದ್ರೆ ಈ ಟೈಪ್ ಮಾಡಿಫೈ ಮಾಡ್ಕೊಳ್ಳಿ. CH3CHOH CH3 ಅಂತ ಬರ್ಕೊಳ್ರಿ. Giving the name becomes easy for you. Since it is a branched compound, therefore I must name it as a isopropyl alcohol ಅಂತ ಹೇಳ್ಬೇಕು. Because it is a secondary alcohol. Clear? And for the third type statement, I'll take acetone. CH3 C double bond O CH3 is acetone. It's a ketone. Ketone with methyl magnesium iodide in presence of ether. You will get three groups: CH3 OMgI as a addition compound. This on acid hydrolysis giving rise to CH3 COH. It is a tertiary alcohol. No need to modify the compound formula. You can accept as it is. You can give the impact name or a common name as a tertiary butyl alcohol. The second and third may not be much more important for theory exam, but first one is compulsory and very important for theory exam also. But second and third also we have taken because could be important for the competitive exams. Clear? ಹೀಗೆ ಒಂದೊಂದೇ different methods for preparation of alcohols we have to study. Second method is by the reduction of the carbonyl compounds. From carbonyl compound, carbonyl compound or carbonyl compound ಅಂತ ಹೇಳ್ರಿ. ಆ ಹೈಫನ್ ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಓ ಹೈಫನ್ ಇರ್ತಕ್ಕಂಥದಕ್ಕೆ ಸಾಮಾನ್ಯವಾಗಿ ಕಾರ್ಬೊನೈಲ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಫಸ್ಟ್ ಅದರಲ್ಲೇ ಫಸ್ಟ್ ಒನ್ ಬೈ ದ ರಿಡಕ್ಷನ್ ಆಫ್ aldehydes and ketones. When aldehyde or ketones, when aldehyde or ketone is reduced into primary alcohol by using either nickel catalyst or palladium catalyst. Therefore, for example, CH3 C double bond OH is hydrogenated in presence of palladium catalyst. You will get the primary alcohol CH3 CH2OH. What you taken at left side? This is acetaldehyde. It is acetaldehyde. Therefore, the product you got is ethyl alcohol. I have given common name. You can consider some other reducing agent. Adanne tagolbekantilla. Sodium borohydride. You can make use lithium aluminum hydride also. You can make use to get the product primary alcohol. But if you taken ketone instead of the primary alcohol, you must expect secondary alcohol. Okay, similar reaction. CH3 CO CH3 undergo reduction in presence of sodium borohydride NaBH4. Sodium borohydride, you will get CH3 CHOH CH3. This is acetone. You will impact upward. It is acetone. This is isopropyl alcohol. Like this, by making use of the aldehydes as well as ketones, by conducting the reduction process using a suitable reducing agent, you will get the products. Okay, reducing agent ಒಂದಕ್ಕೆ ಸ್ಟಿಕನ್ ಆಗಬೇಕು ಅಂತ ಇರಲ್ಲ, ಸೂಟೇಬಲ್ ಆಗಿರತಕ್ಕಂಥ ರಿಯೇಜೆಂಟ್ ಅನ್ನು ಬಳಸಬಹುದು. ಒಂದು ಕಡೆ ಪೆಲೇಡಿಯಂ ಬಳಸಿದ್ದೀನಿ, ಒಂದು ಕಡೆ ಸೋಡಿಯಂ ಬೋರೋಹೈಡ್ರೈಡ್ ಬಳಸಿದ್ದೀನಿ, ಇನ್ನೊಂದು ಕಡೆ ಲಿಥಿಯಂ ಅಲ್ಯೂಮಿನಿಯಂ ಹೈಡ್ರೈಡ್ ಅನ್ನು ಸಹಿತ ನಾನು ಬಳಸಬಹುದು. ಓಕೆ, ಎನಿ ಸೂಟೇಬಲ್ ರಿಯೇಜೆಂಟ್ ಯು ಕ್ಯಾನ್ ಮೇಕ್ ಯೂಸ್. This is the second method. Even you can go for reduction of the carboxylic acid using lithium aluminum hydride. Carboxylic acid ತಗೊಳ್ಳಬಹುದು. When carboxylic acid or COOH is reduced by heating with lithium aluminum hydride, it is giving rise to or CH2OH, that is primary alcohol. For example, when acetic acid is reduced by heating with lithium aluminum hydride, it gets reduced into CH3 CH2OH. This is ethanoic acid you have taken, right? Ethanoic acid, that is acetic acid, giving rise to ethyl alcohol. I have written the PUC name as ethanol. Okay. Reduction by using the Grignard reagent, you have prepared all type of alcohol, primary, secondary and tertiary. Very most important is getting the primary alcohol by using formaldehyde with the Grignard reagent. Second main method is from carbonyl compound, means by using the aldehyde as well as by using the ketones you can prepare the alcohol. When aldehyde is reduced using a suitable reagent, you will get a primary alcohol. When a ketone is reduced using a suitable reducing agent, you will get a secondary alcohol. But when a carboxylic acid is also reduced using lithium aluminum hydride, you will get primary alcohol. every time you must know how to write the general formula and suitable example for those simultaneously. ಎರಡೂ ಬರೆಯಕ್ಕೆ ಬರಬೇಕು. ಜನರಲ್ ಬರೆಯಕ್ಕೆ ಬಂದರೆ ಜನರಲ್ ಬರೀಲಿಕ್ಕೆ ಬಂತು ಅಂದರೆ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಬೇಕು. ಎಕ್ಸಾಂಪಲ್ ಬರೆಯಕ್ಕೆ ಬಂದಿದೆ ಅಂದರೆ ಕಾಮನ್ ಜನರಲ್ ರಿಯಾಕ್ಷನ್ನು ಬರಲಿಕ್ಕೆ ಬರಬೇಕು. We can also have one more equation of the preparation of the alcohol using alkene by the acid catalyzed hydration. Simple. Third method is from alkene by acid catalyzed hydration. For example, CH3 CH double bond CH2 is a propene or a propylene undergo hydrolysis with the help of a acid like H2SO4 CH3 CHOH CH3 I am supposed to write. I should not write it as a CH3 CH2 CH2OH anta baribaardu, because the addition of water to the higher alkene in presence of a acid like a sulfuric acid will also takes place in accordance with the Markovnikov's rule. Therefore, Markovnikov's rule ಪ್ರಕಾರ middle carbon ಒಂದು ಹೈಡ್ರೋಜನ್ ಹೊಂದಿದೆ, ಲಾಸ್ಟ್ ಕಾರ್ಬನ್ ಎರಡು ಹೈಡ್ರೋಜನ್ಸ್ ಗಳನ್ನು ಹೊಂದಿರೋದ್ರಿಂದ addition of water will takes place in accordance with the Markovnikov rule. Therefore, the product formed is not N-propanol, it is isopropyl alcohol. N-propyl alcohol ಬರಬಾರದು, isopropyl alcohol ಬರಬೇಕು ಅನ್ನೋದು method of getting the alcohol from the alkene. Similarly, we have one more method, that is by hydroboration. When a diborane, with the help of a oxidation you can prepare. When a diborane is treated with a higher alkene like a propene, giving rise to trialkyl borane as addition product, which is oxidized further to form the respective alcohol, is the one little lengthy method, maybe of less importance. Then that confirms the methods of preparation of the alcohols. That is, the method heading is preparation of alcohol by hydroboration, that is by oxidation. I'll write the reaction, then I can explain. We have a propene CH3 CH double bond CH2. This is made to react with a diborane. BH3 twice is called diborane. You will get finally you will get trialkyl borane. Onnedu alkyl borane, dialkyl borane. Finally you get trialkyl borane. CH3 CH2 3 times. ಒಟ್ಟಿಗೆ ಬರೆಯೋದಿಲ್ಲ ಇದು. ಫಸ್ಟಿಗೆ alkyl borane, dialkyl borane, trialkyl borane is the product formed. This on hydrolysis with the help of a hydrogen peroxide and acidic medium, will get 3 molecules of CH3 CH2 CH2OH. This is N-propyl alcohol with the boron trihydroxide, BOH twice. ನೋಡ್ಕೊಳ್ಳಿ, ನಾನು ಶಾರ್ಟ್ ಆಗಿ ಬರೆದಿದ್ದೀನಿ. ಏನಂದ್ರೆ ಆಕ್ಚುಲಿ ಹೆಂಗೆ ಹೇಳಬೇಕು ಸ್ಟೇಟ್ಮೆಂಟ್ ಬೇಕಾದ್ರೆ ಹೇಳ್ತೀನಿ. When a higher alkene is made to react with a diborane, addition reaction takes place to form alkyl borane, dialkyl borane, and finally trialkyl borane. This trialkyl borane on oxidation using hydrogen peroxide, it gives propyl alcohol is the statement, but I have written in brief. This is propylene with diborane. You will get trialkyl borane. Tripropyl and alkyl and general akatala. Tripropyl borane. You will get N-propyl alcohol. Ella kadige common name anna kottidini. Okay, these are the different methods for preparation of the alcohols. Briefly, if you want to say about the physical properties, you know, alcohols are the colorless liquids, but they are soluble in water in any proportion. 10 ml of alcohol to 10 ml of alcohol you can add 90 ml of water, or vice versa. To the 90 ml of alcohol you can add 10 ml of water also. In any proportion, alcohol is definitely going to dissolve in the water due to the formation of a hydrogen bonding. Clear? Of course, higher aromatic alcohols they are insoluble in water. I am saying about aliphatic. Aliphatic alcohols are definitely soluble in the water due to the formation of the hydrogen bonding. They can soluble in any proportion is the extra statement. And they will have its characteristic smell that itself is called as a alcoholic smell. Alcoholic smell anna hondirutte antane helbeku, that is its characteristic smell. Then we will go for the different chemical properties in the next class. Thank you.